Hi children! In our previous lesson, we learned how to find the greatest common factor or divisor of two numbers. In today's lesson, we'll cover where the greatest common factor of two numbers can be used. One of the most important subjects in which we use the greatest common factor is the distribution property of multiplication over addition. Now, let's try to explain the subject with a simple example. Let our numbers be 45 and 20. We are making this operation, simple operation. I think you have just found the result as 65. But our subject is not to find the result with this short way. Now I should change this writing to multiplication of two numbers. One of them will be the greatest common factor of 45 and 20, and the second one is the summation of two numbers in the parentheses which have no common factor. So firstly, as you understand, I should find the greatest common factor of these two numbers, 45 and 20. Let's find it. 45, right here 20, our line, famous line, and find a number which divides both 45 and 20 in your head. Which number is not important, but it should divide both of them. 5, for example. After that, if you divide 45 with 5, the result will be 9. And if you divide 20 with 5, the result will be 4. 9 and 4 are the results after dividing with 5 these two numbers, which have no common divisor other than 1. So I reached the result. 5 is the greatest common factor of 45 and 20. So, what I told you before, I should change this summation operation to the multiplication of two numbers, where one of them is the greatest common factor of 45 and 20. I have just found it here, 5 namely. So I should write here 5, then times. The second number will be in the parenthesis, and the sum of two numbers which have no common factor other than 1. These are 9 and 4. So, firstly right here, 5, right here, 45 is the multiplication of 5 and 9. And after that, what about 20? 5 and 4. Multiplication of 5 and 4. Now, after writing this, 5 is the greatest common factor of 45 and 20. And in parentheses, I should write 9. You may get from here. And after that, plus and 4. Now, you may find 9 and 4 by thinking, of course, 5 times which number gives you 45? And 9. certainly. After that, plus sign comes, and then ask the same question in your head. 5 times which number gives you 20 as a result? 5 times 4, of course. You may get 9 and 4 by asking this question in your head. Or after finding the greatest common factor of 45 and 20, you may reach these two numbers at the end. 9 and 4 appears here. They have no common factor other than 1, according to our operation definition. So it means 9 plus 4. 9 and 4 have no common factor, and I changed 45 plus 20 to 5 times in the parenthesis 9 plus 4. Now this is a bit a factorization of these two numbers, these two expression, this expression, sorry, 45 plus 20. 45 plus 20 is a kind of algebraic expression. Now I factorized it 5, and you know the result 9 plus 4 is 13. You may write 5 times 13. 5 and 13 are the factors of 45 plus 20, namely 65. 5 and 13. But my aim is to reach this writing. Okay, now let's give another example. Other than this, one more example, that 66 plus 44. I have two numbers again in summation. Now I should change this operation, the summation operation, to the multiplication of two numbers again. One of these two numbers will be the greatest common factor of 66 and 44, and the other number, the other is in the parentheses, and it should be in summation of two numbers, and these numbers have no common factor other than 1. So now let's try to find the greatest common factor of 66 and 44. Find a number which divides both these two numbers in your head. For example, 11. If you divide 66 with 11, you will get 6. If you divide 44 with 11, you will get 4. After that, I have 6 and 4 after dividing these numbers with 11. 6 and 4 are also divisible by, in common with 2. So divide 6 with 2, the result will be 3. Divide 4 with 2, the result will be 2. After that, I reached 3 and 2, which have no common factor other than 1. So if you multiply 11 with 2, you will get the greatest common factor of 66 and 44. And right here, greatest common factor of 66 and 44 is 11 times 2, which is equal to 22. So let's write here 66. 66 is divisible by 20 with 2. So 66 is equal to 22 times 3 plus, after that, after 66 plus comes, and 44 is 22 times 2 at the end. Now, I should write this operation as the multiplication of the greatest common divisor of 66 and 44 with, and don't write here, don't write multiplication symbol. 22 times which number gives you 66? Now it's here as you see, 3. After that plus sign comes, and after that ask again the question in your head, 22 times which number gives you 44? 22 times 2, this number is here. So I wrote here, this summation operation in a different with a different manner as the multiplication of their greatest common divisor and a number in the parenthesis in summation, of course numbers, two numbers in summation, and these two numbers have no common factor, 3 and 2. So I wrote here 3 plus 2 as you see. Now this is writing the summation or subtraction, you may also write as the multiplication of the greatest common factor of numbers with another number, and this number is the summation of two numbers which have no common factor. Sorry about that. Sorry about that. Now let's continue with the next step. Another place where the greatest common divisor is used is for the simplification of fractions. We use the greatest common factor of numerator and denominator of a fraction to simplify the fraction. Now let's come to the subject with a simple example. So our second title here, simplify fractions by using greatest common factor. You know the fractions very well. Let's write here a number 45, a fraction 36. Now 45 and 36 are integers, and I wrote here a fraction 45 over 36. Now I should simplify 45 and 36 by using which number? I should divide both these two numbers, numerator and denominator, with the same number. And I should find this number. I should think. Now, the first idea is, can you find a number which divides both numerator and denominator at the same time? According to our knowledge, 3, for example, possible. 45 and 36 are both divisible with 3. So divide both these two numbers with 3. If you divide 45 with 3, you will get 15. And if you divide 36 with 3, you will get 12. Now let's continue again, because 15 and 12 has common factors other than 1. Again, these two numbers may be divisible with 3. Let's divide with 3. If you divide 15 with 3, you will get 5. And if you divide 12 with 3, you will get 4. And what about 5 and 4? They are numbers which have no common factor other than 1. So I got the simplest form of the first given original fraction, 5/4. But I reached the result in two steps. In the first step, I divide both numerator and denominator of the original fraction with 3. And again I saw, yes, I may continue, I may divide with another number. Again I divided with 3, and at the end, in the second time, I reached the result, I reached the simplest form. So without making more than one step, only in one step I may find. If I may reach the greatest common factor of 45 and 36, I may find, and if I divide both these two numbers with their greatest common factor, I may reach in a step to its simplest form. So let's try to find in your head or by making our famous operation to find the greatest common factor. Right here 45 and 36. Sketch the line and find the number which divides both these two numbers. 3 is divided with 3. 15 and 12 you get. And after that again 3, 5 and 4. And if you multiply 3 with 3, you will get the greatest common factor of 45 and 36. 3 times 3 gives you this 9. So instead of dividing both numerator and denominator with 3 and after that again with 3, if I divided with 9, I will reach the 5/4 directly with only one step. So now let's continue here. 45/36. Let's divide or write 45 as the multiplication of greatest common factor of 45 and 36. 9 times which number? 5 gives you 45, and 9 times 4 gives you 36. And 9/9 is 1. Make this simplification and the result will be 5/4. That's all. So for all our simplifications on fractions, you should divide both numerator and denominator with their greatest common factor. Okay? Don't forget this subject. Now let's continue with the next one. Greatest common factor of three numbers. Let's give a simple example and pass this title fast. 36 and 20 and another number 24. Okay, these are the numbers I gave you. Now let's try to find the greatest common factor of three numbers. There is no difference on the method. Can you find a number which divides both these three numbers at the same time? 2. If you divide these three numbers with 2, the result will be 436, 18. The result 420. The result will be 10. And what about 24? If you divide 24 with 2, the result will be 12. After that, again 2. If you divide 18 with 2, the result will be 9. 10 with 2, the result will be 5. 12 with 2, the result will be 6. After that, 4, 9, 5, and 6, there is no common factor other than 1. So 2 times 2 gives you the greatest common factor of these three numbers. 2 times 2 is 4. Now, let's continue with the next and the most, I think, one of the most important subjects where we use the greatest common factor in our daily life. It will be very beneficial for us. Word problems on greatest common factor of two numbers or more than two numbers. Now let's read the question and try to understand. For these word problems, if you understand the subject and the question, what the question asks you, then you will solve. First, you will decide. I'll use here greatest common factor. So the clue or the key to solve this question is to understand the question. Meaning of the question gives you may use the greatest common factor. Read it. Brian builds a dog house for his pet. He cuts a long wooden log into two pieces of lengths 48 inches, 72 inches. 48 and 72 inches. Did you understand this? He cuts a long wooden log into two pieces. One of them length 48 inches and the other is 72 inches. If he then cuts, now he is cutting them also. If he then cuts them into wooden planks of equal length, so for 48 and for 72 inches, I should divide them into equal parts. What would be the greatest possible length of each plank? So I have two lengths. One of them is 48 inches. Let denote 48 denote the wooden planks which has 48-inch length. Right here 48. And the second one is this, and it has 72-inch length. Okay, so I should divide them like this, 1, 2, and so on. I should divide them into pieces. Each piece has the same length, and it should have the greatest possible length. So this length or this length, fark etmez. There is no difference between them because they are equal to each other. This length and this length should be the greatest number which divides both 48 and 72. Did you understand what I mean then? What should I tell you? You should find the greatest common factor of these two numbers. Now let's find number which divides both these two numbers. Find 4, for example. This is 18 and this is 12. What about these two numbers, 18 and 12? They are divisible by with 6, 3 and 4. 3 and 4. What about 3 and 4? There is no common number divides these two numbers. So if you multiply 4 with 6, you will get the greatest common factor of 72 and 48. 4 times 6, it's 24. Now it means inch. I wrote here inch. Why? Because 24 inch is the length of each piece. It means if you divide 48 with 24, you will get two pieces from here because 24 is the half of 48. One of them is, they are equal to each other, and 24. If you divide 72 with 24, you will get 3 as you see. So I'll get 3 pieces having equal lengths. 24, 24, and 24. So I took from here 1, 2, 3, 4, 5 pieces, equal pieces from my equal pieces from 48 and 72 lengths. And of course, what question asks? What would be the greatest possible length of each blank? So the answer is, we should find the length of each piece. The answer is 24 inch. Okay. Okay. I think you understand the meaning. Now let's continue with the next. It's Mona's birthday today. She buys 84 pencils, 63 erasers, and 42 sharpeners to distribute to her classmates. Before she gives them away, she packs them in several pencil cases, each case holding the same number of items. How many classmates could Mona have at the maximum? At the maximum. How many friends? At the maximum number of friends. Number of friends should divide 84, 63, and 42 at the same time and should be the greatest. I reached this result in a short time. I think you also reached. So I should find the greatest common factor of these three numbers, 84, 63, and 42. Let's find. If you divide these numbers with 3, and you will get 28. If you divide 63 with 3, you will get 21, and 42 with 3, 14. Now, what about 28, 21, and 14? 7. 7 is the common factor. If you divide 28 by 7, you will get 4. 21 with 7, you will get 3. 14 with 7, you will get 2. So 4, 3, and 2. There is no common factor divides three numbers. So if you multiply these two numbers, 3 and 7, you will get the greatest common factor of 84, 63, and 42. 3 times 7 is 21. So the number of friends of Mona should be 21. Greatest number of friends should be 21. Now I think let's check on the next page. There is no question. So we have just finished our lesson today. So please concentrate on the examples on this video and try to understand all meanings and all places where we may use the greatest common factor. So hope to see you on the next lesson. Bye.